Good morning, children. Let us start chapter number 3, Metals and Non-Metals. Physical properties of metals. Metals are solids except mercury. Mercury is the only metal which is present in the liquid state at room temperature. Metals are hard except lithium, potassium and sodium. Lithium, potassium and sodium are soft metal. They can be cut through knife. Metals have metallic luster. Metal give the shining property. You can see the gold, silver, all are having the shiny property. Metals are malleable. Metal can be beaten into thin sheets. We get aluminium sheet, gold foil sheet. So metals can be beaten into thin sheets. Metals are ductile. They can be drawn into wires. So we can get copper wire, aluminium wire, etc. Metals have high melting points. Gallium and cesium have low melting point. They melt in palm of the hands. Now metals have high boiling points. All metals are mostly having the very high boiling points. Metals are good conductors of heat. Best conductors are silver and copper. Poor conductors are lead and mercury. Metals are good conductor of electricity. Best conductors are silver and copper. That's why copper is used for the wire for electricity. Metals are sonorous. They produce sound or melodious sound when beaten. All musical instruments are made up of metals. Physical properties of non-metals. Non-metals may be solids, liquids or gases. Solids are carbon, sulfur, phosphorus, etc. Liquid non-metals are bromine. Gases, oxygen, hydrogen, nitrogen, etc. Non-metals are soft except diamond, which is hardest known substance. Non-metals do not have luster. That means they do not shine except iodine crystals. Non-metals are non-malleable. Non-metals are non-ductile. It cannot be stretched into wire. Non-metal which are solids and liquids have low melting points. Non-metal which are solids and liquids have low boiling point also. Non-metals are bad conductor of heat. Non-metals are bad conductor of electricity. Exception is graphite. And non-metals are non-sonorous. Chemical properties of metals. Reaction with oxygen. Metal reacts with oxygen to form metal oxides. For example, when copper is heated, it combines with oxygen to form copper oxide. You can write the reaction like 2 copper plus oxygen, O2 gas gives 2 CuO, 2 molecules of copper oxide. Likewise, when aluminium is heated, it combines with oxygen to form aluminium oxide. 4 molecule of aluminium plus 3 oxygen molecule combine to form 2 Al2O3 or aluminium oxide. Some metal oxides are basic oxides because they react with water to form bases. For example, when sodium reacts with oxygen, it forms the sodium oxide. 4Na plus O2 gives Na2O, sodium oxide. And when this sodium oxide combines with water, it gives NaOH, sodium hydroxide, which is base. Likewise, potassium when combined with oxygen, it forms K2O, potassium oxide. And again, when potassium oxide combined with water, it gives 2KOH molecule or potassium hydroxide molecule. So, metal oxide when combined with oxygen gives the bases. That's why known as basic oxides. Some metal oxide shows acidic and basic properties. They are called amphoteric oxide. Example, aluminum oxide, zinc oxide, they are amphoteric oxide. They both show acidic and basic properties. We can see the reaction. Aluminium oxide, Al2O3, when react with acid, HCl, it gives the aluminium chloride plus water. In this, aluminium oxide acts as basic oxide. Again, when aluminium oxide, Al2O3, combined with base, NaOH, sodium hydroxide, It gives the sodium aluminate plus water. In this case, it reacts with base and it acts as a acidic oxide. Reactivity of different metals with oxygen is different. Example, metals like potassium and sodium reacts vigorously with oxygen and catches fire if it is kept in open. Hence, they are stored in kerosene to prevent burning. If magnesium is heated, it burns with bright flame. If iron is heated, it glows brightly. If copper is heated, it does not burn but form a black coating of copper oxide. Silver and gold does not react with oxygen even at very high temperature. Some metals like magnesium, aluminium, zinc, lead, etc. forms an oxide layer over it and which prevent them further oxidation. That is why they are known as self-protecting metals. Reaction of metals with water. Now metal react with water to form metal oxides or metal hydroxides and hydrogen. For example, when sodium reacts with water, it forms sodium hydroxide along with hydrogen gas. When potassium also reacts with water, it forms potassium hydroxide along with hydrogen gas. Calcium with water forms the calcium hydroxide. Aluminium with water forms aluminium oxide. Iron with water forms ferric oxide along with hydrogen gas. The reactivity of different metal with water is also different. Like sodium and potassium react violently with cold water to form sodium hydroxide and hydrogen and catches fire. Calcium reacts less violently with water to form calcium hydroxide or slaked lime and water and does not catch fire. Magnesium reacts only with hot water to form magnesium hydroxide and hydrogen. Metals like aluminium, iron, zinc react only with steam to form the metal oxides and hydrogen. And metals like lead, copper, silver and gold do not react with water. Reaction of metal with acids. Now metal react with dilute acid to form salt and hydrogen. Example, magnesium is reacting with hydrochloric acid to form magnesium chloride plus hydrogen gas. Aluminium, when react with hydrochloric acid, it forms aluminium chloride and 3 molecules of hydrogen gas. Zinc, when combined with hydrochloric acid, it forms zinc chloride and H2 gas. And again, when iron combined with hydrochloric acid, it forms ferric chloride plus hydrogen gas. The reactivity varies from metal to metal. For the above metal, the decreasing order of reactivity is magnesium, aluminium, zinc and iron. Copper, silver, gold, they do not react with dilute HCl or dilute hydrochloric acid. Hydrogen gas is not evolved when metal react with nitric acid because it is a strong oxidizing agent and it oxidizes the hydrogen produced to water and it itself reduced to oxides of nitrogen. For example, we can see when copper react with nitric acid, it forms copper nitrate plus water, not hydrogen gas, and plus nitric oxide. Reaction of metals with metal salt solutions. Now, a more reactive metal displaces a less reactive metal from its salt solution, and this reaction is known as displacement reaction. For example, magnesium displaces copper from the copper sulfate solution. We can see the reaction Mg magnesium plus CuSO4 copper sulfate gives MgSO4 magnesium sulfate plus Cu, that is copper. So here you can see magnesium is replacing copper from its sulfate solution. Likewise, zinc displaces copper from copper sulfate solution. Zn plus CuSO4 gives ZnSO4 plus Cu. Again, iron displaces copper from copper sulfate solution. Fe, iron, plus CuSO4 copper sulfate, it gives FeSO4, that is iron sulfate, plus copper. Now you can see in the pic, when magnesium powder is added in copper sulfate solution, which was blue color, reaction happens and magnesium sulfate is formed, which is colorless. In the second case, when nail is added in blue color of copper sulfate solution, after 10-15 minutes you can see the change of color, that is formation of iron sulfate, green iron sulfate solution you can see. So this color change shows that these metals are more reactive than the copper. Reactivity series of metals. The arrangement of metals in decreasing order of their reactivity is called reactivity series of metals. For example, most reactive metal we can learn is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. Silver, gold, they are noble metals. They are less reactive. Reactivity decreases when we move from top to bottom of the series. Now, how do metals and non-metal react? Metal loses electrons and form electropositive ions. So, they are known as electropositive elements. Metals are electropositive. Example, atomic number of sodium is 11. Its electronic configuration is 281. It has one valence electron, or outermost electron is 1. When it loses one electron and forms sodium ion, Na plus ion, you can see sodium loses one electron and it becomes electropositive Na plus. Now you can see atomic number of sodium is equal to 11. Electronic configuration we can write 281. When it becomes electropositive and Na plus, the electronic configuration changes from 281 to 28. And likewise magnesium, when it forms Mg2 plus ion by releasing 2 electrons, atomic number of magnesium is 12. Electronic configuration we can write 282. And when it forms or lose 2 electrons, the electronic configuration changes from 282 to 2 and 8. So metals loses electron and become positive ions. Again, for non-metals, it gains electron and become negative ions. So they are known as electronegative elements. Metals are electronegative. Non-metals are electronegative. Example, atomic number of chlorine is 17. Its electronic configuration is 287. It has outermost electron or valence electron 7. When it gains one electron and form chloride ion Cl minus, then Cl plus one electron, it gains Cl minus. Atomic number initially was 17. Now electronic configuration we can write is 287. When it gains one electron is added in the valence shell and its electronic configuration changes to 288. So oxygen likewise gain 2 electron and its configuration changes to O2 minus. Formation of sodium chloride molecule NaCl. Here you can see Na is metal and chlorine is non-metal. When sodium has atomic number 11, we can write electronic configuration 281. Likewise, chlorine has atomic number 17. We can write electronic configuration 287. Sodium has 1 valence electron and chlorine has 7 valence electron. When the reaction happens, sodium loses its one outermost electron and attains the configuration of 28, and chlorine accepts 1 electron and attains the configuration of 288. So Na forms sodium forms the positive ion, and chlorine, by accepting the electron from the sodium, it forms the chloride or negative ion, and the common salt formula is NaCl. And the attraction between Na plus ion and Cl minus ion results in the formation of sodium chloride molecule. The atomic number of magnesium is 12. Its electronic configuration is 282. It has 2 valence electron or outermost electron, so it loses 2 electron to form Mg2 plus. The atomic number of chlorine is 17. Its electronic configuration is 287. It has 7 valence electrons, so it gains 1 electron to form chloride ion, NaCl-. Then the attraction between Mg2 ion and 2 chloride ions results in the formation of magnesium chloride, MgCl2. Ionic compounds or electrovalent compounds. Ionic compounds are compounds formed by the transfer of electron from a metal to a non-metal. Properties of ionic compounds are they are formed by transfer of electrons and are made up of ions. They are crystalline solids. Mostly they are present in the crystals. They have high melting and boiling points. They are soluble in water but insoluble in organic solvents like petrol, kerosene, etc. They conduct electricity in their molten state or in the solution. Occurrence of metals. Some metals like gold, silver, platinum, etc. are found in free state in the earth crust because they are least reactive or they are noble elements. Most metals are found as oxide form, carbonates, sulfide, halide forms, etc. Minerals are elements or compounds which occur naturally inside the earth crust. Ore is the mineral from which metals can be extracted profitably, and gangue are the impurities present in the ore like rock particles, sand particles, clay particles, etc. Now we have to extract the metal from their ore. So during the process of extraction, metals are extracted in the 3 main steps. They are first concentration of ore, or we can also know it as the enrichment of the ore, reduction to the metals, and refining or purification of metals. First is concentration of the ore or enrichment of the ore. It is the removal of gangue particle or impurities, as we have talked, like sand, clay particles and rock particles from the ore by different methods. Steps involved in the extraction of metals from their ores. Now, ore of the metals can fall in the metals of high reactivity. Now, metals of high reactivity can be extracted by electrolysis of molten ore and we get the pure metal. If the metal lies in the medium reactivity, we found carbonate ore of these metals or sulfide ore of this metal. Now, carbonate ore contains oxygen itself, so it undergoes calcination or heating of the carbonate ore in absence of air, and we get the oxide of metal. And sulfide ore do not contain oxygen in its ore, so it will undergo roasting, means heating of sulfide ore in presence of air is known as roasting, and we get the oxides of metal and we reduce the metal, or finally we refine the metal. And metals can fall also in low reactivity. So metal having low reactivity is mostly found in sulfide ore. So we undergo the roasting process or heating the sulfide ore in presence of air. We get the metal and finally we refine the metal. Now, extraction of metal low in the reactivity series. Metal which are low in the activity series can be reduced to metals by heating in the presence of oxygen or roasting. Example, mercury is obtained from its ore like cinnabar, HGS, which is sulfide ore, by heating in the presence of oxygen. When it is heated in presence of oxygen, it is first converted to mercuric oxide, and on further heating it reduces to mercury. You can see the equation HGS or cinnabar, when heated in presence of oxygen, O3O2 molecule, it forms the mercuric oxide, and when again mercury oxide is heated, it forms the mercury and oxygen. Likewise, copper is obtained in sulfide form, CuS, copper sulfide, and in heating in the presence of oxygen, it gives copper oxide, and when copper oxide and copper sulfide heated, it gives copper plus sulfur dioxide. Extraction of metals in the middle of the activity series. If metal lies in the middle of the reactivity series like zinc, iron, lead, They are found in the form of oxide, sulfide or carbonate ores. It is easier to obtain metal from their oxide than their sulfide or carbonate. So, non-oxide ores are converted into oxide ore first before reduction. Non-oxide ores can be converted into oxide ore by either roasting or calcination. Roasting is the heating of ore in presence of oxygen. It is used to convert sulfide ore into oxide form. Example, zinc sulfide when react with oxygen, when it is heated, it forms the zinc oxide plus sulfur dioxide. This is roasting or heating of the sulfide ore in presence of oxygen. And calcination is the heating of an ore in absence of oxygen. It is used to convert sulfide ores into oxide form or carbonate ores into oxide form. Example, zinc carbonate, when given heat, it forms the zinc oxide plus carbon dioxide. The oxide ore is then reduced to metal by heating with the reduction agent. The most common reducing agent is coke or carbon. So example, zinc oxide heated with carbon, it forms the zinc metal plus carbon monoxide. Thermit reactions. Sometimes reactive metals like sodium, calcium, aluminium, etc. are used as reducing agents to obtain metals from their oxides. Example, manganese dioxide, MnO2. 3 molecules when combined with 4 aluminium molecule, they form manganese and aluminium oxide plus heat. The reaction between metal oxide and aluminium is highly exothermic, or it liberates the heat in the large quantity, and the metals are obtained in molten state. Such reaction is known as thermit reactions. The reaction between iron oxide and aluminium produces molten iron. This reaction is used to join rail tracks, broken machine parts, etc. Like iron oxide Fe2O3, when react with aluminium, it form aluminium oxide plus iron. Iron is in the molten state plus heat. It is exothermic reaction. This is the picture of thermit weld, which is used to join the railway track. Last is extraction of metals at the top of the reactivity series. Now, metals at the top of activity series like potassium, sodium, calcium, aluminium, etc. cannot be obtained from their ores by simple heating or by heating with reducing agents. They are obtained by electrolytic reduction of their molten chlorides. How we will do the electrolytic reduction? When electric current is passed through molten sodium chloride NaCl, sodium metal is deposited at cathode and chlorine gas is deposited at anode. At cathode, sodium accepts electrons and it forms sodium metal, and at anode, chloride releases electron and forms the chlorine gas. Refining of metals. The removal of impurities from the metal to obtain pure metal is called refining of metals. The most common method for refining is the electrolytic refining. In this method, a block of impure metal is made anode and thin sheet of pure metal is made cathode. The electrolyte is the salt solution of the metal to be purified. Example, in the electrolytic refining of copper, a block of impure copper is made as anode and thin sheet of pure copper is made as cathode. The electrolyte is acidified copper sulfate or CuSO4 solution. When electric current is passed through the electrolyte, pure copper from the anode is deposited at the cathode and the impurities settle down as anode mud. Corrosion. Corrosion is the damage caused to the metals due to reaction of metal with oxygen, moisture, carbon dioxide, etc. Example, formation of brown coating of rust over iron. Formation of green coating of basic copper carbonate over copper, and formation of black coating of silver sulfide over silver. To show that air and moisture are necessary for rusting of iron, we can do one activity. Take 3 test tubes, mark 1, 2, 3 and put iron nails in each of them. Now put some anhydrous calcium chloride in test tube 1 to absorb moisture. Pour some boiled distilled water in test tube 2 and pour some oil over it to prevent air into the test tube and pour water in test tube 3. Now cork the test tube and leave them for few days. The nail in the tube 1 do not get rusted because it has only air and no water. And in the nail in the test tube 2 does not rust because it has only water and no air. And in nail 3, test tube 3, it get rusted because it has both air and water. Prevention of corrosion. How we can prevent the rusting or corrosion of the metals? First is by applying oil or grease, by applying paint, or by covering or giving the coating of zinc metal. That process is known as galvanization. By tinning or providing the coating of tin, or by electroplating, coating a less reactive metal like chromium on the more expensive metal. By alloying or by making alloys or mixing metal with metal or metal with non-metals. So, alloy is a homogeneous mixture of a metal with other metals or metal with non-metals. Example, stainless steel or steel. Steel is made up of iron and carbon. Stainless steel is made up of iron, carbon, cobalt and nickel. Brass is made up of copper, zinc. Bronze is made up of copper, tin. Solder is made up of lead and tin used for welding electrical wires together. If one of the metal in an alloy is mercury, it is known as amalgam. For example, zinc amalgam, mercury amalgam, etc.